Distinguished guests, faculty, staff, students, and friends, Namaste, and a very good afternoon to you all. On behalf of the seminar committee, I, Shobhan Majumdar, welcome one and all to today's Foundation Day celebration. Today we gather not merely to observe an anniversary, but to celebrate a vibrant tapestry woven with threads of scientific brilliance, relentless innovation, and unwavering national commitment. We assemble to commemorate the 41st Foundation Day of our center. 41 years ago, on this auspicious day, the 19th February 1984, the foundation stone of this esteemed institution was laid by the then President of India, Gyani Jail Singh. As we reflect on the remarkable achievements of RRCAT over the past 4 decades, we are reminded of the foresight and leadership that guided this establishment. This center, named in honor of the eminent scientist Dr. Raja Ramanna, a key architect of India's nuclear program, embodies his spirit of scientific inquiry and his commitment to self-reliance in advanced technologies. Today, we are especially honored to have with us a distinguished individual who embodies the very essence of scientific leadership and national service. Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India, and a distinguished physicist renowned for his pioneering work in condensed matter physics. A very welcome, sir, to RRCAT. Your presence here today is a source of immense inspiration for us all. We also acknowledge with profound gratitude the presence of our esteemed former directors, Professor P.D. Gupta, Professor Naik, and Dr. Nakhe, and the former group directors, Dr. Rawat, Dr. Uh, and many others I am not seeing here. So, who have dedicated their expertise and leadership to nurturing this institution. Their wisdom, guidance, and unwavering commitment have been instrumental in shaping RRCAT into the center of excellence it is today. Furthermore, we are delighted to welcome the distinguished directors, vice chancellors, and professors from various universities and academic institutions. The eminent doctors, the esteemed member of the press, who serve as conduits of information and enlightenment, and our valued industry partners, whose collaboration is essential to translating scientific discoveries into tangible progress. A sincere and heartfelt welcome is extended to all our guests joining us online, connecting with us virtually on this special occasion. To my esteemed colleagues, both senior and junior, and to our brilliant students, the future architects of scientific innovation, I offer my warmest greetings on this proud and momentous occasion. Thank you all for your presence here today, for your shared passion for scientific exploration, and for your belief in the transformative power of knowledge. To commence our celebrations, I respectfully request our Honorable Chief Guest, Professor Ajay Kumar Sood sir, to kindly grace the dais. I request Sri Unmesh Malsiji, Director of RRCAT, and Sri Tusham Pundabigarji, Additional Director RRCAT, to kindly escort our distinguished Chief Guest. Thank you, sirs. I now request our Honorable Director, Sri Malsashab, to formally welcome our esteemed Chief Guest with a sapling. Thank you, sir. No auspicious occasion can well begin without the invocation of the Almighty. We commence this auspicious occasion with a moment of reverence. I request all dignitaries on dais to kindly join us in invoking the blessings of Devi Saraswati, the goddess of knowledge and wisdom, through the lighting of the ceremonial lamp. I request Ms. Avantika Gautam to assist the dignitaries in this ceremony. I request you please wait for a moment. As many of you are aware, this year marks the birth centenary of Dr. Raja Ramanna, a truly distinguished scientist and a pivotal figure in India's nuclear energy program. In recognition of his invaluable contributions, this center was renamed as the Raja Ramanna Center for Advanced Technology in 2005 by the Prime Minister of India. Dr. Ramanna also served as the former chairman of the Atomic Energy Commission and secretary to the Government of India. This year, we also mourned the loss of another eminent personality, Dr. Rajagopala Chidambaram, a renowned physicist who played an integral role in India's nuclear weapon program. Dr. Chidambaram also served as the former chairman of the Atomic Energy Commission and secretary Department of Atomic Energy, and as former principal scientific advisor to Government of India. I request the dignitaries on dais to kindly pay floral tribute to the memory of Dr. Rajaraman and Dr. Chidambaram. Thank you, sirs. For the benefit of those present, it is important to recall that Rajaramanna Center for Advanced Technology was established by the Department of Atomic Energy, Government of India, with a mandate to conduct cutting-edge research and development in two strategically vital domains of science and technology, lasers and particle accelerators. These are not merely fields of scientific inquiry, they are enabling technologies that underpin advancements across a spectrum of critical sectors, including medicine, industry, defense, materials, and science. The pursuit of excellence in these domains is essential for national progress and technological self-reliance. On February 19, 1984, a significant milestone was reached when the foundation stone of the center was ceremoniously led by then President of India, Gani Joel Singh. This marked the commencement of a journey of scientific exploration and innovation. The center's scientific endeavor formally began in June 1986 with the arrival of the pioneering group of scientists from the Bhabha Atomic Research Center, Mumbai. Since that time, RRCAT has steadily and impressively ascended to the forefront of scientific institutions in India, earning widespread recognition for its substantial contributions to research, development, and applications of lasers, accelerators, and related technologies. As we gather today to celebrate the 41st Foundation Day of RRCAT, we not only commemorate the past, but also reaffirm our commitment to the future of scientific advancement. I'm particularly pleased to announce that these proceedings are being broadcast online to designated venues within the RRCAT campus, as well as to other units of the Department of Atomic Energy. This arrangement ensures that our valued colleagues who are unable to be physically present with us in this auditorium can nonetheless participate virtually in this important celebration, fostering a sense of shared purpose and collective achievement. I now invite Sri Tushar Puntambekarji, Additional Director RRCAT, to offer his opening remarks.
Respected Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India, Shri Unmesh D. Malche, Director RRCAT, Dr. Shovan Mujumdar, Director MSITG, former Directors of RRCAT, Dr. P.D. Gupta, Dr. P. N. Naik, Dr. S.V. Nake, former Group Director, Dr. Anil Rawat, invited dignitaries and esteemed guests, members of DSC and SCR, senior officials, heads of division, sections, and labs of RRCAT colleagues, representatives from industries, members from press and media. Very good afternoon to all of you. On behalf of the Ramanna Center for Advanced Technology, I am honored and delighted to extend a warm welcome to all of you, this Foundation Day function of 2025, which is the 41st Foundation Day. This day has a special significance for all of us, as the foundation stone of the center was laid by the then President of India, Honorable Shri Gyani Jail Singh, on February 19, 1984. The center was established by the Department of Atomic Energy to expand the activities carried out at BRC Mumbai in two frontline areas of science and technology, namely lasers and accelerators. Since then, the center has rapidly grown into a premier institute for research and development in lasers, accelerators, and their applications. The center was renamed as Ramanna Center for Advanced Technology by the then Prime Minister Honorable Dr. Manmohan Singh on 17th December 2005, in the honor of Dr. Ramanna, a distinguished nuclear physicist who played a crucial role in the establishment of this center. Dr. Ramanna, a visionary scientist, recognized the growing importance of lasers and particle accelerators in various fields, including research, industry, and medicine. He envisioned a dedicated research center to foster indigenous development in these cutting-edge technologies. This foresight led to the establishment of RRCAT in 1984. He played a crucial role in the initial planning stages of RRCAT, which included identifying the specific areas of focus for the center, ensuring alignment with the national priorities and scientific advancements, and selecting the location for the center, considering factors like infrastructure, accessibility, and proximity to other research institutes. Dr. Ramanna's contribution to RRCAT went beyond administrative and strategic planning. He was a source of inspiration and guidance for the entire team, fostering culture of scientific excellence and innovation. His vision and leadership have shaped RRCAT into a premier research institution, contributing significantly to India's advancement in lasers, accelerators, and related technologies. As we gather here to celebrate our Foundation Day, we are reminded of the importance of our mission to advance the frontiers of knowledge, foster innovation, and contribute to the betterment of society. It is a mission that requires unwavering commitment, curiosity, and a spirit of collaboration. As we embark on the next chapter of our journey, let us remain inspired by the vision and legacy of Dr. Ramanna. In conclusion, I would like to once again welcome each one of you to this momentous occasion. Together, let us celebrate the past, embrace the present, and look forward to a future filled with promise and potential. Thank you.
Thank you, Tusharji. Now, as per established tradition of our Foundation Day, the Director of RRCAT presents a concise report on the center's activities and accomplishments during the preceding year. I now invite Sri Malche Saab to present the RRCAT annual report for 2023-24. I request the dignitaries on dais to kindly be seated in the audience.
Mouse.
Yeah. A very good afternoon to all. Let me first thank our chief guest, Professor Sood, for accepting our request to be the chief guest of this important event of Ramanna Center for Advanced Technology, that is Foundation Day, 41st Foundation Day. As a matter of fact, I sent a mail requesting him to be the chief guest for this event. The mail was sent at around say 5:15 in the evening, and in another 1.5 hours, I got his reply that he has kindly accepted to be the chief guest for this. So I thank you once again. Sir, please accept our thanks on behalf of RRCAT as well as on my own behalf uh, to be the source of immense inspiration, encouragement for RRCAT family. I also former group directors of RRCAT for gracing this occasion. And also should not forget the heads of institutes, academic institutes, and their representatives, eminent representatives, to be part of this important function of RRCAT. The seeds of formation of Center for Advanced Technology was sowed in early 80s. I'll not repeat the things which was mentioned by my colleagues, Dr. Shovan and Tusharji, that it was founded, the foundation stone was laid down on 19 February, and on December 17th, it was renamed as Ramanna Center for Advanced Technology after Dr. Ramanna. But as Dr. Mujumdar mentioned that the previous year was the centenary year of Dr. Ramanna, I would like to proudly inform the audience that the Indore Municipal Corporation has named the square just outside RRCAT campus as Dr. Ramanna Square on our request. So it is a great matter of pride for all RRCAT family members. So this is the beginning. We started our activities in sort of multiple shades somewhere in the year 1986-87, and the right-hand side picture is a symbolic representation of growth in 40 years. It is a picture of our Indus facility. And this growth in past 4 decades has taken place under the leadership of 8 former directors of RRCAT. So let us thank all of them for steering these activities and taking the RRCAT to this location. So the expansion of RRCAT, it expanded. Initially, I was told that there were only 2 groups, accelerator group and laser group. These groups are now increased to 5 groups: proton accelerator group, electron accelerator group, laser group, material science and advanced technology group, and technology development services group. So the name of group itself indicates the nature of activities of that group. In addition to the development of laser and photonics, the laser group is also involved in LIGO activities. IRFL activities are covered by material science and advanced technology group, and in addition to the Indus operation, electron accelerator group is coordinating the activity of designing and planning high brilliance synchrotron radiation source that we are working on it. Currently, the proton accelerator group is developing RF systems for industrial accelerators as well as electron accelerators for HBSRS. The technology development and support group, which is comprising of industrial accelerator division, which is developing industrial accelerators for processing food commodities, or it is being used for medical sterilization. In addition, there are 3 more divisions: design, manufacturing, technology division, construction services division, computer division. All these divisions under technology development service group, they are providing good support to all 4 remaining groups. In my presentation, I'll not be covering the activities group wise, but rather I would like to cover the activities as per the R&D areas. And these are the R&D areas in which I will be proceeding. It will start from the facilities for researchers, students, and industries across the country. Accelerator development activities, which will be these accelerators will be other than SRS, that is synchrotron radiation source, as well as IRFL. Then the developments in the area of light and laser technology and associate technology developed with these light as well as lasers. Of course, for these type of developments, you need a strong technology development group, and so this will be covered under a section called supporting technologies development, and the technologies that we are developing. Now, to grow our Indian industry, it is necessary to transfer these technologies, and so this will have 2 advantages. One is the industry will grow when we transfer this technology, which finds applications other than our own applications. But at the same time, we also become free to carry out developments and carry out other research R&D activities. And for these activities, the support in proper infrastructure is also required, and the supporting infrastructure development, which is carried out by our technology development and TDSG group, that will be covered. So let me start with the facilities for researchers, students, and industries across the country. Though RRCAT is operating 2 national facilities since long, I'll start with the new entrant to these facilities, and that is, the first one is IRFL, that is infrared free electron laser. This was formally opened for outside users which are outside from RRCAT on 2nd December by Secretary, Department of Atomic Energy, Dr. Ajit Mohanty, and the first users are from TIFR as well as IIT Bombay. This IRFL facility has been developed with having 4 stations. One is a station for diagnostics for IR beam diagnostics. The second is irradiation of samples, particularly bio and chemical samples. Then the frequency domain station, or rather carrying out the frequency domain spectroscopy. And the 4th one is the wavelength measurement using Michelson interferometry. So the blue color blocks in the blue color indicates that these stations and these things are available, or rather they are ready. The remaining things are planned in future. So this IRFL is basically optimized to deliver a pulsed IR radiation ranging from 12.5 to 50 micrometer wavelengths. It can complement the Indus facility because for the low photon energy, because it can consistently deliver the the radiation at this whatever wavelength has been indicated. And the port for time domain and pump probe spectroscopy, as I mentioned, they are planned in future. So basically here the preliminary experiments were carried out at this IRFEL, and the left hand side graphs shows that consistently the spectral brightness of more than 10 to the power 12 photons per second per mm square per millirad square with a 0.1% bandwidth for the entire wavelength ranging from 12.5 to 50 micron is available. And moreover, higher brightness of the IRFEL brings out the features which cannot be observed using some lab sources like FTIR, which is shown over here on the right hand side. The second facility is which is being commissioned, or rather it was commissioned. Its commissioning started around 1.5 years ago, but now a few experiments were carried out in this calendar year, or rather in 2024. And these experiments basically, of course, this petawatt laser it's a chip pulse amplification based laser system supplied by Thales, France, having 25 joules energy with a pulse duration of 25 femtoseconds, which makes the power to 1 petawatt. It has got a wavelength of 80 nanometer and repetition rate is 0.1 hertz. So laser beam, after the pulse compression, is transported through the vacuum line. Basically, you can see the vacuum line over here to a shielded experimental hall where these evacuated plasma chambers are placed, and the experiments are carried out in these chambers. So two types of experiments were carried out. One is the electron acceleration and the proton acceleration. The electron acceleration was up to 500 MeV was demonstrated, and the proton acceleration was demonstrated to 6 MeV. The target for electron acceleration is to achieve 1 GeV acceleration, and that will provide a short femtosecond X-ray source for the time resolved X-ray absorption spectroscopy type studies. The target for proton acceleration is to achieve around 50 MeV for various proton driven experiments as well as neutron interaction studies. So let us come to the status of synchrotron radiation source Indus 1, Indus 2, which are operating in round-the-clock mode since February 2010. In this year, the 20th beamline got ARB clearance. This beamline is photo emission electron microscopy beamline BL22. So this has taken total number of beamlines of Indus 2 to 20. Particularly in this 2024, the best performance in terms of number of operating hours has been recorded by Indus 2 facility, which is 5840. Both these facilities, Indus 1 as well as Indus 2, are being utilized by universities and institutes. Around 140 universities, institutes are utilizing this facility. Approximately, say, around more than 1,000 experiments are consistently being carried out for last 3 years, which has resulted in 2024 the number of publications to 242. Now, in addition to these academic institutions, the Indus 1, Indus 2 beamlines are also being used by Indian industries, particularly the pharmaceutical industries. So that has now penetrated to the pharmaceutical industries as well. I mentioned that while the performance of the Indus 2 in terms of number of operating hours in the calendar is found to be the best, deep is observed in the Indus 1 operational hours. And this was primarily because the Indus 1 was taken up for a major upgradation in the previous year, but then it was completed in the last year. So because of this, the Indus 1 was not available for the experiment for a small duration. So during this major upgradation, New vacuum chambers with additional diagnostic services have been installed. New combined function magnets were installed. This use of these combined function magnets, because they are compact in size and we have a space constraints, we have to carry out the upgradation in the available space. So this was the best option available to introduce a combined function magnet that was introduced. Then slow orbit feedback has also been deployed, and these upgradations have resulted improvement in the beam quality. Particularly, the event of beam killing in Indus 1 without giving any obvious reason has reduced to nil. Earlier, these incidences were around say 2 to 10 every month, and the availability of the measurement as well as correction of the beam orbit has resulted in the improved synchrotron radiation beam stability. And this beam orbit, the beam orbit drift of around 80 micrometer is now being maintained within plus minus 30 micrometer with the slow orbit feedback system. After operation of Indus 1, Indus 2 since long, now there is a need for fourth generation synchrotron radiation source has been there is a need, or rather this fourth generation is needed. Synchrotron radiation source is needed, and this need is primarily because we need the high brilliance to carry out or to look into the minor features or phases with high throughput and fast samplings. We need increased proton energy so that the penetration of X-rays can be enhanced, and we also need the reduced focal spot, which will increase the phase contrast for fast full field imaging. So if we see the current status of fourth generation SRS synchrotron radiation sources in world, there are 3 SRS operating in the world, and all these fourth generation SRS are having a range of energy range ranging from 3 GeV to 6 GeV, but the emittance is 133 picometer at ESRF EBS, and at Brazil and Sweden it is 280 and 250. But in addition to this, 2 more sources are either under construction phase or in advanced commissioning phase. Particularly APSU, to the best of my understanding, is either fully commissioned or is in the advanced commissioning phase. These 2 sources are having 42 picometer rad as the emittance. There are many more under planning, and India is one of them. We are proposing to establish a synchrotron radiation source which will be identified as Indus 3 with 6 GeV energy with 150 picometer rad. Now, the parameters of this synchrotron radiation source, our fourth generation synchrotron radiation source, Indus 3, is a result of a guidance from our today's chief guest. We thank him for the guidance and the support that he has provided. RRCAT is getting an opportunity to establish such facility because of his support only. He communicated and convinced the authorities for establishing that about the need of establishing this HBSRS, which will be another national facility benefiting many departments of Government of India, and RRCAT will be in a position to establish this facility. So with his support, we are getting an opportunity. The current, and after these parameters were finalized, we approached Atomic Energy Commission for the project approval, and we have received in principle approval from Atomic Energy Commission with 3 stipulations. That is, we have to carry out, or rather the machine design must be reviewed by international experts, the cost must be reviewed by independent experts within the country, and the beamline specifications must be finalized in consultation with the users from various academia as well as various departments of ministries of Government of India. So the status is as follows. The machinery, the international expert panel was constituted, and it has we had more than 2 or 3 meetings, and it is converging. Maybe the next meeting will be the final meeting in which they will be giving a concluding report, and but till today, their impression or their based on the interaction with them, it appears that they are confirming that there is no conceptual fallacy in the design that we are working on. So basically, that is a good sign, and it is giving a boost for our colleagues to go ahead with the cost estimation and drafting the DPR, which will be submitted for the approval of competent authority. We have submitted this conceptual design document, overview document, to this international panel having these sections, and this document is a result of culmination of the efforts of various groups working in Raja Ramanna Center for Advanced Technology. They have in a very short notice, all of them have worked out and drafted these sections, which has been reviewed on a very short notice. Maybe in a period of say 1 or 1.5 months, this activity has been completed. This is basically the specification of high brilliance synchrotron radiation source, that is Indus 3. You can see that the brilliance or the emittance will be almost 300 times of the existing Indus 2, and the peak brilliance will be 5 order higher. In fact, the spot size also will be significantly small as desired. And the mode of operation of Indus 3 will be, it will be operating in top-up mode, so that the maximum availability can be ensured for the users when the Indus 3 is operating. Where do we stand with respect to taking ahead this HBSRS project? We have the basic infrastructure is available with us. RRCAT has sufficient land to establish this Indus 3. We have water, electricity, and approach is also available for carrying out the construction activities. This RRCAT is coming under this Madhya Pradesh Pollution Control Board, for which we have already a clearance available, and the process is underway to obtain clearance from AERB as well as MOEFCC. We are well prepared with available able technical and human resources who have extensive experience in designing as well as operating Indus 1, Indus 2, as well as IRFEL or Linux, or they are also involved in international accelerator projects also. So in a nutshell, we are very much well prepared for taking ahead with this HBSRS activity, which will be our next goal or next target for our Amritkal program. But for Indus 3, this will be altogether a 4th generation synchrotron radiation source, which will require some developmental activities for developing few components, few systems, which will be first of a kind, or maybe whatever capacities we have, we may have to extend it. Either their size needs to be increased or capacity needs to be increased. So one of them is the brazing of accelerating structures. The industry, it is envisaged that the LINAC will have 4-meter long accelerating structures. This 500 MeV LINAC. Now, 4-meter long accelerating structures, either machining or fabricating will be difficult. So basically, it will require a brazing joint. So for brazing, the one option is either to go for expensive furnace brazing, which will accommodate the entire 4-meter long structure. But the alternate, our colleagues have worked out the alternate to this, in which the localized vacuum will be created, and wherever this brazing joint is coming, and this will be heated with an induction source. So the induction source has been developed. It has been demonstrated. A 100 kilowatt induction heating power source is demonstrated. The main requirement is to attain 500 degrees centigrade in the shortest possible time. So achieving this 500 degrees centigrade in 120 seconds, you can see in this graph, with 85 kilowatt power has been demonstrated. And for this, the FBG, that is fiber brick grating based temperature measurements and UHV compatible optical fibers which were developed at RRCAT have been used or deployed. Now, another area of development is developing various components or subsystems, which includes developing magnets and power converters. So, in this area, we already have carried out simulation and the design for this longitudinal gradient, dipole magnet, dipole quadrupole combined magnet, as well as pulse sextupole magnet. The design is over, this analysis is over, and we are entering into the fabrication of these components. 1.2 meter long undulator for Indus 2 has been developed, and we will be extending the same for Indus 3 with 2.5 meter long undulators. The vacuum chamber components as well as SIP neck pumps are also developed. Rather, vacuum chambers have been designed for the vacuum chamber having the coating of neck. Inside this vacuum chamber, you need a separate facility, because these are thin and very long sections which run from basically the length of these sections is of the order of 6 meters, and for which today itself, in presence of our chief guest, we performed a Bhumi Puja to establish that facility, and that facility will be coming in another 2 or 3 years. In addition, high resolution beam diagnostic devices as well as machine control electronics is also developed. So let me come to the accelerator development, which is, these accelerators are other than SRS as well as IRFEL. In the proton accelerator development, long back RRCAT initiated the development of proton accelerator for spallation research. And these accelerators, this accelerator was envisaged to operate in pulse mode with accumulator ring kind of arrangement. The know-how gained, in fact, on the right-hand side, you can see these bullets. These are the components which were developed for this 1 GeV pulse proton linac with a duty cycle of 10%. So the knowledge gained in developing these components, designing these components, will be very much useful and can be extended for DAE's proton accelerator program. So DAE's proton accelerator program is basically, maybe you may all may be knowing that in our recently concluded in the last year, this Chintan Shivirs and Chintan Baithaks, DAE is envisaging establishing a 1 GeV continuous wave proton accelerator as one of the DAE's Amritkal target. So whatever information or the knowledge gained during the development of our pulse mode proton accelerator can be extended for this development. In addition, DAE is also taking part into Indian, or rather it has Indian institution and Fermilab collaboration for in-kind contribution towards 800 MeV proton linac, which is being established at Fermilab in USA. So again, the knowledge gained over here is also useful in developing indigenous proton accelerators. And in this IIFC collaboration, RRCAT is also contributing in the in-kind contribution. As you can see, in fact, if you see this 800 MeV linac, almost in each and every section, Department of Atomic Energy is contributing, right from the cryo plant till this is HB 650 elliptical cavities. Particularly from RRCAT point of view, we are supposed to deliver HB 650 cavities as well as 40 kilowatt and 70 kilowatt solid state amplifiers to Fermilab. So right now the current state is we need clearance from Fermilab in terms of, or rather in the form of FDR, that is final design review at Fermilab for both these amplifiers is over, and we will be starting the manufacturing of these amplifiers soon. As far as these elliptical cavities are concerned, RRCAT has already established a required infrastructure for carrying out cavity forming, EB welding, dressing facilities, and we already have developed maybe a few number of cavities in past to Fermilab, which were tested, and then a positive response has been received from Fermilab. However, now in the previous year, we have extended the support to carry out the fabrication of single SSR2 cavities, that is single spoke resonator type 2 cavities, which is coming under purview of Bhabha Atomic Research Center, and they wanted help in terms of the EB welding. So since the facility was established based on the request from BRC, RRCAT has extended its support to carry out the EB welding. They also carried out they also carried out the developmental activities to design and develop fixtures, fit-ups for EB welding of these cavities. So another important deliverable under R&D phase of this IIFC collaboration. Basically, this IIFC, the PIP2 is being constructed, or the project is being executed in two phases. The first phase was R&D phase, in which the technology was supposed to be demonstrated, and then they were going to enter into the construction phase. So as a part of this R&D phase, RRCAT has to deliver horizontal test stands. Basically, it is a cryostat. So RRCAT has two systems were procured. One and both the systems were procured with the support from Indian industry only. The first system is installed at RRCAT, and the second system is being dispatched. In fact, this item is being dispatched today itself to Fermilab. So it will be maybe after a period of say 1-2 months, it will be reaching Fermilab. Another important development is the developing niobium with high RRR characteristics. So this for superconducting cavities are fabricated from the niobium of very high RRR. NFC Hyderabad and RRCAT had initiated this activity to develop these ultra high pure niobium ingots from the reactor grade niobium. This reactor grade niobium is having a RRR value of around 20 to 30, and for these superconducting cavities, the niobium RRR requirement is around 300. So high purity niobium ingots are manufactured by iterative melting by NFC, and melting by NFC, and these samples are provided to RRCAT to carry out the measurements of the RRR values. So if you see in this graph, basically this year we received the samples from the second campaign. Basically these three are the second campaign. The remaining the solid lines, basically they represent the samples that were received in the first campaign, and these samples in the first campaigns were received in I think 2023, last year. But the issue was observed, that is between the third cycle to fourth cycle a dip was observed, and primarily this dip was because the vacuum was not proper from when they go for the fourth cycle. This was because of the seals were leaking. However, at that time, NFC was not having any device to carry out or to detect any kind of a leakage. So RRCAT was having a gas analyzer. So that gas analyzer was installed to NFC furnace, and then the second campaign was initiated. And as you can see that in the second campaign, consistently the higher the RRR rating is consistently increasing. So now we expect that the next one more cycle will deliver the product of the desired properties. The another important requirement of this proton accelerator is developing a zero gap brazing technique for fabrication of RFQ structures. These RFQ structures are copper structures, long copper structures, and which needs to be brazed. So it is desirable to have a zero gap brazing, because otherwise the material may flow inside and may deteriorate, or maybe the RFQ structure itself may not be acceptable. So for that, our colleagues have developed a zero gap brazing technique, and this technique involved, or rather this development involved evolving specific lay and texture to be generated during the milling operation. Then another requirement was to study the proper, whether the brazing material is having a proper wettability or not. And the third most important thing was to maintain the uniform temperature along the entire length within a range not varying beyond 3 degrees centigrade during 140 hour long quasi-static heating cycle. So this technique has been developed, and in the RFQ structure has been brazed, and it is undergoing the test and trials. Another important technique for processing the elliptical cavities, that is superconducting elliptical cavities, was developed. It is a novel plasma processing system for multi-cell SCRF, that is superconducting radio frequency cavities, was developed. The 5-cell cavities was subjected to this type of processing, and the results, encouraging results were obtained. In fact, this technique gives the required properties or the surface finish required for this operation of this superconducting cavities. So now, after this proton accelerator, the next section is electron accelerator for societal applications. We started the development of this electron accelerators way back in 2017 with 10 MeV 6 kilowatt, and now in due course of time till today we have manufactured 4 Linacs, gone up to 10 MeV 15 kilowatt energy, and we target to develop 10 MeV 20 kilowatt in another 2 to 3 years. The first one that was developed in 2016 is operating at our ARPF, that is Agricultural Radio Processing Facility near Sabji Mandi, and it is being used for sterilizing the medical devices. Till today, 75 lakhs medical devices have been sterilized. In fact, since December, they have sterilized 25 lakhs medical devices. So this requirement is, really a remarkable achievement. This is basically developing. We already have developed 10 MeV 15 kilowatt Linac with energy limiting device for food irradiation. The first 2 Linacs were not provided with the energy limiting devices. Basically, it is a stringent requirement that the energy at no point of time should exceed 10 MeV. So this energy limiting device comprises of a 270-degree magnet, in which the higher energy range particles, they are separated, and we are able to control the energy to say 9.5 MeV, and we are not allowing the particles with energies more than 9.5 energy. And in addition, only few countries are able to make high power linear industrial Linacs, which include USA, Belgium, China, France. So we are one among them. This 15 kilowatt Linac, it used a constant gradient accelerating structure. So we in-house developed the manufacturing, measurement, conditioning, and beam qualification setup for this constant gradient accelerating structures for this 15 MeV 15 kilowatt Linac. Now, these Linacs, E-Linacs will find, or rather they are finding applications in food, for food irradiation as well as for medical sterilizations. So once it is well accepted, and when its requirement will significantly increase, it is not cup of tea of RRCAT to carry out this type of mass production of such type of e-linac. So we need to handhold with the local industry for manufacturing these e-linac technologies. And with that objective, a theme meeting was held at RRCAT on September 14th. 2024 with most of the manufacturers, around 20 Indian industries participated, and they showed a willingness for manufacturing various Linux systems. In addition to that, it is necessary to minimize the import content of this e-linac. Right now, the klystron is one of the component that we need to import. So RRCAT is also contributing to the indigenization of the klystron. They have their own indigenization program, as well as they are shaking hands with the BRC. In fact, at BRC also this development is going on. And for collaborating with industry, we are signing incubation MOU agreement with ECIL for developing 10 MeV Linac with 18 kilowatt or more power. Now let me come to the developments in the area of light and laser technologies and the applications developed with these technologies. So the laser technology, a high power ND-YAG and fiber lasers we are developing out of this, the fiber coupled pulse ND-YAG laser with 40 kilowatt peak power and 2 kilowatt average power has already been developed. Actually, this laser is using 4 numbers of 500 watt laser systems, which are making this power to 2 kilowatt. And these lasers will find a potential applications for carrying out the aging management activities in the nuclear industry. Particularly, it can be deployed for the NMAS coolant channel replacement, or it can be used for laser cutting of thick components. In fact, it can be used for submerged laser cutting and welding. And when I say submerged laser cutting, it need not be underwater. It can be under some liquid metal cutting or welding also. So this laser will be available. Let us see the requirement. Whenever it comes, we will be ready to deploy it immediately. A fiber bragged grating based load cell has been installed at WIP, that is WMD, West Management Division of BRC, for indexing a system in the CS filling system, indexing system of the CS filling facility. CS is basically cesium. So cesium generally it is being used as a irradiator, or it is being used as a source, and the source of any radiation emitting substance depends on the mass, and there we need a very high sensitivity, particularly the weight measuring, or rather for measuring this. The weight range is from 0 to 1000 grams, that is 1 kg with accuracy of plus minus 5 grams. And this system must operate under a very high radiation, high radiation environment, because cesium is highly radiating material. So this we have developed and deployed at WMD in this year. The laser induced breakdown spectroscopy is one another technique that can be used for quantifying the low Z elements in the minerals, basically. This laser-induced background spectroscopy, it works on the principle that when the laser is shined on the material sample, it vaporizes, and this emits radiation of different wavelengths depending on the elements in the sample. So once this type of method or instrument or equipment is fully established, it will be very much useful for quick analyzing the carrying out elemental analysis of the mineral samples. In fact, we received 5 mineral samples: spodumene, then feldspar, beryl, muscotive, and NB titanium alloy from AMD to determine the concentration of lithium as well as beryllium. Now, this laser-induced breakdown spectroscopy exhibits some complex behavior. That is, its peak intensities vary non-linearly and different peaks respond differently. So for that, machine learning analysis or rather machine learning module has been incorporated using artificial neural network. The relative mean error with available samples that were provided was found to be less than 2.5% for all concentrations of lithium and for higher concentrations of beryllium. But in case of beryllium with lower concentration, this RME, that is relative mean error, was a bit higher. It was 9.5%, and primarily this error was because number of samples were very less. So once the number of samples will increase, this definitely this RME will be also improved. We use the light for carrying out developing few equipments or devices that can use in the healthcare. One such equipment is oncodiagnoscope. Oncodiagnoscope is a photonic based device developed by RRCAT. It uses principle of difference in fluorescence signature between healthy and abnormal tissues for screening oral cavities. So as one of the targets identified for Platinum Jubilee celebration of Department of Atomic Energy, the target was to carry out uh, cancer screening in around more than 70 camps across India. And so this point of care device has been used in over 70 cancer screening camps in which around 8,000 individuals were screened, and out of which 700 were identified having potential malignant or malignant oral lesions or conditions for timely intervention. Another important development is carry out the clinical studies on antimicrobial photodynamic therapy. The antimicrobial photodynamic therapy, in this, the microorganisms retain some photosensitizers. Basically, you can see this tube. So when these photosensitizers are spread, they are retained in the microorganisms, and when light of appropriate wavelength is shined on these microorganisms, it gets excited to react with surrounding oxygen molecules, which generates reactive oxygen, which helps in the early curing or fast disinfecting the disease or whatever wound is there. The another industrial application of the light is measuring the wall thinning for the end plug of the PFBR fuel pin. So a shadowgraphy technique has been deployed, and this system has been commissioned at a fuel fabrication facility at BRC Tarapur. It can measure, or rather 60 pins per hour, it is, or rather 1 pin per minute. It is able to inspect at that rate. And basically this will reduce the man rem significantly, because all these pins are plutonium loaded, and plutonium is a radioactive element which emits radiation. So that will help in reducing the man rem consumption. In the laser developmental activities with respect to the laser, it is necessary to indigenize for carrying out the imports or to have import substitute. For high energy lasers, right now we are importing the glasses that are required for high energy lasers. So indigenous development of the laser glass has been taken up in collaboration with CGCRI. The development of laser glass is defect free, that has been observed, but the optical homogeneity is 10 to the power minus 3 against the requirement of 10 to the power minus 5. So RRCAT has taken up a project to optimize and improve this optical homogeneity to 10 to the power minus 5. And I think, and my colleagues have got some sort of progress in this activity. So they are now developing a semi-continuous laser glass melting facility. It is designed based on directly heated platinum technique, and it uses a proper mixing when the glass is being melted and poured. So that will minimize, or rather that will lead to achieving the required homogeneity that we need for this lasers for the high power high energy lasers systems. One more important responsibility of RRCAT is contribute to the laser interferometer gravitational wave observatory. As you all know, the LIGO India was inaugurated by Honorable Prime Minister on 11th May 2023, and RRCAT is one of the unit which is contributing to this LIGO India project. So the status is basically land has been acquired, site office at Hingoli. This LIGO India project is coming up at Hingoli in Maharashtra state. The site office is ready. The internet lease line for data connectivity has been established. With respect to the transfer of advanced LIGO detectors, MOU between DAE and LIGO labs have been signed, and now I think we will start receiving these detectors from LIGO lab, that is Caltech. At site, there is a need to diverse some roads that is a requirement of this. It is a technical requirement, and for diverting that particular load, we have to acquire some land which was coming under the forest. So we have to give alternate land for the forest, and that land has been identified, and the diversion land for the approach road is being handed over to forest department, which will make our which will facilitate to provide the alternate approach road for this LIGO facility. The most important thing is this LIGO facility, the total estimated cost of this EPC tender for construction is almost around 1,600 crores, and this will be carried out in one single mode. Both civil and vacuum infrastructure will be the establishment of the civil and vacuum infrastructure will be simultaneously done within a single contract. Now, basically, the stringent requirement is a civil requirement. Even you all know that Earth has a curved surface, so we have to take care of this curved surface also while construction. So that level of accuracy is required for the civil construction. So therefore, it calls for a quality-oriented project, and the approval of the quality-oriented project has been accorded, and now the project or the EPC contract is being executed under the quality cum cost based selection criteria. The vendors will be selected, and shortly the EPC tender will be floated. Recently, on 2nd of December, our secretary, Dr. Ajit Kumar Mohanty, he inaugurated the offsite testing and training facility. This facility, in addition to testing and training, it will also serve as an assembly and staging lab for the LIGO detector systems that we will start receiving in couple of months from now. So while the construction at the project site is in progress, so that there will be a staging, and then these detectors also will be tested at the facility inaugurated by Dr. Mohanty. Now, for carrying out all these developments, we need a technology, and this technology needs to be developed. And as I mentioned, this technology also needs to be transferred to Indian industry. So AIC PiHub, a Section 8 company with 100% equity holding and by DAE, hosted at RRCAT, has been formed, and it is mandated for translation of the technology, know-how, expertise to the Indian industry and to the startups in the following modes that I have presented over here. That is the technology transfer, through the technology transfer through the value addition to the in-house technology. Now, when I say in-house technology, the technology available in RRCAT, if needs some value addition, the industry can come forward and suggest, or otherwise, if industry has some ideas and RRCAT has got expertise, we can have a collaboration with the industry to develop a few systems. then we can provide a consultancy services as well as advanced training and certification courses. So AIC Pi Hub on the AIC Pi Hub day, we entered into 5 agreements or 5 events were concluded on that day. That is on 4th of September 2024. The first one was the TIG welding machine for joining solid to porous materials by Metals and Membranes Private Limited located in Indore was signed. The second one was a 2 kilowatt fiber laser based lamp machine was launched by one of our incubator, V-Fuse Metal. It is a startup, and this machine was launched on 4th of September. Then on that day, we signed MOU with LPSC, that is Liquid Propulsion System, ISRO, for developing the LAMP technology for building liquid oxygen methane bimetallic thrust chamber. The technology transfer agreements were signed with Lab to Market Innovations for Agni Rakshak, and technology transfer agreement was also signed with RJ Instruments Mumbai for a single stage 30K class cryoclear with helium compressor. So these agreements were signed on the 4th of September. Among this full penetration TIG welding was one of the challenging thing. Basically, as you can see, this TIG welding of solid and porous pipes is a challenging, because on one side you have a solid pipe and other side you have a porous material. This porous material is used for the filtration in many chemical industries. So that joining, if you go for joining that particular thing, either it will crack or may not be successful. So RRCAT, in association with the Metals and Minerals Indore, they developed a special purpose welding machine, which was launched, or rather which is now ready for carrying out its operation. Now, for carrying out these developments, we need supporting infrastructure as well. So the security is of prime importance. Now, security is either IT security, information technology security, or a physical security as well. So for IT security, our computer division is developing secure software agents for both Microsoft operating system as well as Linux operating system, and it is based on the intranet endpoints to collect and dispatch telemetry data related to software programs, network interface, assigned IP address, and ARP cache to the central server. They have also developed ML-based endpoint security and reconnaissance attacks detection and monitoring system also. For physical security, commissioning of video surveillance setup along the perimeter of RRCAT technical area has been commissioned. Almost 124 numbers of IP cameras with 6 number of embedded network video recorders and video management with dedicated IP networks have been commissioned. The civil and electrical and mechanical infrastructure, which is looked after by CSD. This year, the solar power generation has been enhanced by 110 kilowatt photovoltaic power. Out of this 110, 60 kilowatt photovoltaic solar PV has been set up in the parking area behind A1 block, and 50 kWp rooftop solar PV power generation plant has been set up on HBNI rooftop. And both these plants are connected to grids, and around 4 lakh units per year is being harnessed. Now in future we will be developing HBSRS, and we need to obtain MOEF clearance. So generally, when we approach MOEF for giving any clearance, generally they look they are concerned about the forest. So if more number of trees are coming into, or rather they are becoming a hurdle, you have to eliminate them. But while giving approval, they stipulate that you should plant more number of trees than you are cutting. So towards this, RRCAT is entering into the forest, urban forestation, and a Miyawaki forest has been developed just to show that we are simply not planting, but we are taking care that the plants also grow. And in 2021, the Miyawaki garden near the Nakshatra garden was planted, and this is the current status in 2024. Similarly, this is the west side HBNI, west side of the HBNI. This plantation was done in 2022, and this is the current status. So this much growth has taken place, and that means the plants are growing. It's not simply you plant and forget it. The another important thing that our people have done is deep root irrigation. All of you must have heard about the drip irrigation, but the deep root irrigation is the water will directly go to the deep roots that are deep underground. So this has got many advantages. I have listed over here. I will not go through that because of the time constraint, obviously. But then this technique has also has resulted a good fruits to RRCAT. So to end, let me thank all RRCAT, my colleagues, all the groups, all the divisions, sections, sales, labs in RRCAT are contributing to the achievements of the center with full vigor. In Amritkal period, we have to put much more efforts to reach the goal of Viksit Bharat. And these targets are really tough targets. The major goals include contribution to LIGO, establishing a high brilliance synchrotron radiation source, that is fourth generation synchrotron radiation source, indigenizing high power laser systems, developing industrial linear accelerators for food preservation as well as medical sterilization. And these developments will not only make us grow, but it will also facilitate the local industry to grow and become competitive. I mean, the local industry will become competitive internationally. So that will be another advantages, hidden advantages that we can see. And all of us will keep putting our best efforts in striding forward with the team spirit and enthusiasm and accomplishing the goals towards Viksit Bharat. Dhanyavad. Light.
Thank you, sir, for your report. Uh, Now I request Professor Sood, Director sir, and Tusharji, please come on stage. Thank you, sir. As Sri Manshi Sahab has mentioned, we now transition to a particularly significant segment of our program that embodies the very essence of RRCAT's mission, the lab to land ceremony. This ceremony is not merely a formality, it is a celebration of the successful culmination of scientific inquiry, technological innovation, and entrepreneurial spirit. It underscores RRCAT's unwavering commitment to translating cutting-edge research into tangible benefits for society. Through our incubation center, we empower innovators to transform RRCAT developed technologies into commercially viable products. Today, we will have the distinct honor of witnessing the launch of several such products, each representing a testament to the ingenuity and dedication of our incubatees. Moreover, we will solidify new collaborations through the signing of incubation agreements with the esteemed industry partners who have demonstrated their confidence in the transformative potential of our technologies and their commitment to bringing them to a wider market. It gives me great pleasure to announce that we are honored by the presence of our valued industry partners who have partnered with us in this Lab to Land initiative, joining us today for the launch of products developed using RRCAT technologies and the signing of new incubation agreements with the AIC Pi Hub. Their presence underscores the importance of collaboration in bringing scientific breakthroughs to market. The Lab to Land ceremony is a testament to the collaborative efforts that drive innovation. To guide us through this important segment of our program, I now call upon Dr. C.P. Paul, whose leadership as Head of Engineering, Design and Manufacturing Division and Head of the Atal Incubation Center Pi Hub at RRCAT is instrumental in fostering this crucial link between research and commercialization. Doctor, please take the stage.
Thank you, Dr. Majumdar. Respected Chief Guest of the Foundation Day celebration, Professor A.K. Sood, Principal Scientific Advisor, our beloved Director, Shri Unmesh Malche, Additional Director Puntambekar Sir, Dr. Shovan Majumdar, Chairman Seminar Committee RRCAT, distinguished guests of the dais, correspondent from the press and the media, colleagues and friends. Like yesterday, for the Lab to Land ceremony, affirming the DAE commitment for the translation of RRCAT technologies, know-how, and the expertise to Indian industries and startup, we are again present here. In last 2 years, we have signed 32 agreements, 6 product launch based on our technologies, and all these are now available with the industries and the startup. Sir, as already pointed out, we are 100% equity holding company of DAE hosted at RRCAT. And whenever I speak AIC Pi Hub, it means management and coordination team of AIC Pi Hub, various technology development division sections of RRCAT, and many agencies that are supporting the technology translation activities that we are undertaking. As you know that we have 5 major mode of operations: technology transfer, value addition to the in-house technology, collaborative technology development, consultancy and services, and also the advanced training and certificate program in the niche areas. This year, we received 16 technologies requests for the transfer, development, product launch from the various divisions and the sections. But due to the paucity of time, we are only limiting the function to the 6 technologies this time. And all are representing all the 5 parts that we are working on. As you know that we have developed first engineering prototype of 10 MeV 15 kilowatt LINAC and successfully demonstrated its operation. The technology has high potential for the irradiation of the food, medical items, and many industrial items. There is a need of around 20 such systems in the country, and it's going to increase with the time. Recently, we received a request from the Electronics Corporation of India Limited, Hyderabad, to develop and value add to the existing technology that we have at the 15 kilowatt machine to increase it to 20 kilowatt level under the collaborative technology development. We worked on this, and I just want to mention the autonomy it gives, the framework it provides. We are able to shape the agreement and whole process within 45 days. Now I request Shri R. Balachandran, General Manager, and Shri J. Suryanarayana, Senior Deputy General Manager from ECIL Hyderabad, to come on the stage for the Lab to Land ceremony. I request Shri Rajeshwar Singh Sanda and Shri T. Raghu to join the celebration. Sir, please. I just want to mention that ECL team is working hard, and they have promised that beam processing for addition facility for Indian industries will be available by January 2027. AIC Pi-Hub will help them. All the AIC Pi-Hub will not only support this technology, but also extend help in making the necessary infrastructure which is required for E-beam radiation facility. Thank you. As you know that the government of India issues many legal and travel documents, and they have got many security features. And these features, some of these features are already used, are made using CO2 lasers. And these CO2 lasers had been imported by the country, but now efforts are being using the existing know-how and expertise to develop the technology of refurbishing of the CO2 laser systems and the power supplies in the country. I would like to mention that India Security Press, which has Nasik, has come forward, and they are establishing a state-of-art facility at AIC Pi-Hub, which will be operating at B block as a part of the state-of-art facility, and which will be a dedicated facility for repairing of the such systems by ISP Nasik to cater the requirement of the repair of the CO2 lasers and power supplies for coming 8 years. Now I request Shri Rajesh Ji Bansal and his team to come on the stage for the lab to land ceremony. I also request Dr. Manoj Kumar and Shri Amod Tuk to join representing the technology development team. Shri Bansal Ji is a senior chief general manager at ISP, and Jitendra Kumar Ji is the senior DGM at ISP. I would like to mention that RRCAT has already repaired 63 such systems, and now under this agreement, we'll be again repairing 87 more systems in next 8 years. If you remember properly, last year we signed an agreement for extending the spare capacity of FPG grating inscription facility to Indian industry and startup, so that they can use this facility and test the thing. Now things are giving results and coming into the shape. Mission Critical Photonics Private Limited, a newly incorporated startup, plans to establish a dedicated facility at AIC Pi-Hub for the incubation of production-ready FPG sensors. These FPG sensors will be used for various applications, including structural health monitoring, industrial sensing, and biomedical equipments. I request Professor S.K. Sinha and Shri Piyush Vijay to come on the stage for the lab to land ceremony. I request Dr. Om Prakash and Dr. Jitendra Kumar to join representing technology development team. I just would like to mention that Professor Sinha started this company when he was 67-year-old after superannuating from ISC Bangalore. And now he has a second venture. And I would like to mention one more thing, that AIC PIHB is not only the first incubation center in DAE, but also now first AIC taking 5% stake on MCP in mission critical photonics in terms of the technology development. Last year, an agreement was signed. An agreement was signed with CFF Fluid Control Limited, Mumbai, for the development of the technology of liquid nitrogen-based fire extinguishing system for dousing major fires on board sea-going vessel. These fire extinguishing systems will also need fire sensor, and you know that Agni Rakshak is the one of the best solution for it. Now, RRCAT with Agni Rakshak is in position to provide a complete package from sensing to dousing of the fire for onboard sea-going vessel. I request team from CFF Fluid Control Limited, Mumbai, to come on the stage for lab to land ceremony. I request Dr. Om Prakash and Dr. Manoj Saxena to join representing the technology development team. One point more, so we noted that this is the 8th technology of Agni Rakshak is being transferred to India. It is transferred to the 8th industry. So you can wait, you can stay. आप दोनों जा सकते हैं. There is always a question in our mind, whatever the technology we are making here, is it going to the people? Or is there any buyer? Now, to support this cause, today we have a hand transfer of technology in a product by a company who took the technology from us and giving it to the CFA Fluid Control Limited, Mumbai. I request Mr. Sanjay Mittal and team from Formmac Engineers who took the technology of Shivai from us, and now they want to sell this product to CFF Fluid Control Limited, Mumbai. Mittalji, please come on the stage. As a symbol, Mr. Mittal will present key of Shivai to CFF. Heel over hand where is. So it shows that the technology is speaking and we are going for another way. And you know that Shivai has got really unique technology. It finds application in fruits and vegetable, fish, pharma, and other perishable refrigeration transport. All these things are efforts, Atma Bharat ki or ek aur kadam. We know that DAE is technology hub, and we are at AIC Pi Hub are sitting on the heap of high-end technologies. However, the market needs something more than that, other than being the expert in the technology, to translate and make it more viable. Hence, we come up with the strategic partnership alliance with Indian School of Business, Hyderabad, to work together for promoting technologies and supporting startup ecosystem in big way. We have today Mr. Naman Singhal, Chief Executive Officer of AIC Indian School of Business, Hyderabad, for Lab to Land ceremony. I request Dr. Anurag S.D. Rai, Chief Executive Officer of AIC Pi Hub, and Mr. Praveen Kumar, co-convener of AIC Pi Hub, the coordination committee, to join. As I mentioned that there need to be a strategic alliance. So Indian School of Business will be helping us and making a business models and pushing it to the next level for the startups and make the things to this. With this, I stop today's land to land ceremony here. Thank you very much for being and patient listening to us.
Thank you, Dr. Paul. As we celebrate the 41st Foundation Day of RRCAT, we are extremely delighted to have with us Professor Ajay Kumar Sood, Honorable Principal Scientific Advisor to Government of India. We express our sincere gratitude to you, sir, for gracing this occasion with your presence. Though Professor Sood's eminence in the scientific community is widely recognized, yet for the benefit of the wider audience, I would like to briefly highlight his distinguished contributions before inviting him to address us. Professor Ajay Kumar Sood, born in Gwalior on June 26, 1951, is a distinguished scientist and a leading figure in the field of condensed matter physics. His remarkable career has been marked by groundbreaking research, innovative discoveries, and a deep commitment to advancing scientific knowledge. He embodies the spirit of scientific inquiry and has made significant contributions to our understanding of the fundamental properties of matter. Professor Sood's academic journey began at Punjab University, where he earned his graduate and master's degree in physics. His pursuit of knowledge led him to the prestigious Bhabha Atomic Research Center Training School in 1972, marking the beginning of his illustrious research career. He is the product of the 16th batch of BRC Training School. He then joined the Indira Gandhi Center for Atomic Research, Kalpakkam, where he worked as a scientist until 1988. During this period, he simultaneously pursued his doctoral studies at the Indian Institute of Science, Bangalore, culminating in the award of his PhD in 1982. His thirst for knowledge and pursuit of excellence took him to the Max Planck Institute for Solid-State Research, Stuttgart, Germany, where he conducted postdoctoral research from 1983 to 1985, further honing his expertise in condensed matter physics. In 1988, Professor Sood joined his alma mater, the Indian Institute of Science, as an associate professor, marking a pivotal moment in his career. He quickly rose through the ranks, becoming a professor in the Department of Physics and eventually serving as the chairman of the Division of Physical and Mathematical Sciences until 2008. His long association with IISc has been instrumental in shaping his research trajectory and fostering a vibrant scientific community. Since 1993, he has also held the position of honorary professor at the Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore, further demonstrating his commitment to research and education. Professor Sood's research spans the vast landscape of condensed matter physics, encompassing both hard and soft matter. His contributions are characterized by remarkable breadth and depth, ranging from the fundamental properties of materials to their potential applications. His work has explored the exciting world of low-dimensional materials, including graphene, nanotubes, and other nanomaterials, which hold immense promise for technological advancements. He has also made significant contributions to the understanding of nanoscale devices, technological insulators, Dirac and Well semimetals, ultra-fast spectroscopies, squeezed and coherent phonons, ultra-high pressure Raman studies, glass transition in colloidal matter, driven complex fluids and RRCAT, flux in active granular matter, stochastic thermodynamics, and even bacterial heat engines. This diverse portfolio reflects his intellectual curiosity and his ability to tackle complex scientific challenges. One of Professor Sood's most notable achievements is the discovery of the Sood effect in 2003, where he demonstrated the generation of electrical signals by passing liquids through nanotubes. This groundbreaking discovery has had a profound impact on the field of nanotechnology and has opened up new avenues for sensing, energy harvesting, and other applications. His research on optical phonons in various materials, including semiconductor superlattices, fullerenes, and carbon nanotubes, has yielded valuable insights into fundamental vibrations of atoms and their interactions with light. He was also the first to successfully excite squeezed phonon states in KTAO3 crystals, a testament to his mastery of advanced experimental techniques. Professor Sood's contributions extend beyond fundamental research. He has also invented an ultra-sensitive immunoassay with significant implications for medical diagnostics and has developed a medical diagnostic kit with broad applicability. His current research focuses on enhancing the viscosity of materials with nanotubes with potential applications in creating lighter and more effective bulletproof vests. Professor Sood's exceptional contributions to science have been recognized with a remarkable array of prestigious awards and honors, a testament to the profound and lasting impact of his work. These accolades include the Santi Sarup Bhatnagar Prize, one of India's highest scientific awards, recognizing his groundbreaking research in condensed matter physics. He is also a recipient of Padma Shri, India's fourth highest civilian award, bestowed upon him for his distinguished service in the field of science. Further underscoring his international standing, Professor Sood was awarded the Third World Academy of Sciences, that is TWAS Prize in Physics by the World Academy of Sciences, acknowledging his significant contributions to physics in developing countries. His election as a fellow of all three Indian science academies, the Indian Academy of Sciences, the Indian National Science Academy, and the National Academy of Sciences India, is a rare and distinguished honor, reflecting the high esteem in which he is held by his peers within the Indian scientific community. His fellowship in the World Academy of Sciences, and most notably his election as a fellow of the Royal Society, one of the world's most prestigious scientific societies, solidify his place among the global leaders in science. Beyond these notable achievements, Professor Sood has also been the recipient of several other significant awards, including the G.D. Birla Science Award, the Federation of Indian Chambers of Commerce and Industry FICCI Award, the Materials Research Society Medal, the Millennium Gold Medal of Indian Science Congress, Homi Jahangir Bhabha Medal of the Indian National Science Academy, the Indian Institute of Science Alumni Award, the M.N. Shah Birth Centenary Award of the Indian Science Congress, the Sir C.V. Raman Award of the University Grants Commission, the Goel Prize in Physics, the D.A.E. Rajaramanna Award from the Jawaharlal Nehru Center for Advanced Scientific Research, the National Award in Nanoscience and Nanotechnology from the Department of Science and Technology, and a Lifetime Achievement Award from Punjab University, Chandigarh. His contributions have also been acknowledged through the Bhatnagar Fellowship of the Council of Scientific and Industrial Research, the Vigyan Ratna Award from Punjab University, Chandigarh, the H.K. Firodia Award in Science and Technology, the Bangalore Nano Award from the Government of Karnataka, the G.M. Modi Award for Science, the Indian Science Congress Award for Outstanding Contributions to Science, and the R.D.Birla Award for Excellence in Physics from the Indian Physics Association. This extensive list of accolades reflects the breadth and depth of Professor Sood's contributions to the scientific community. Professor Sood's influence extends beyond his individual research achievements. He holds the Bhatnagar Chair, a prestigious position recognizing exceptional contributions to science, further emphasizing his leadership in the field. His service in prominent leadership roles within numerous scientific organizations demonstrates his commitment to fostering scientific excellence and collaboration. He has served as the President of Indian Academy of Sciences, guiding and shaping the direction of scientific inquiry in India. As Vice President of the Indian National Science Academy, he played a crucial role in promoting scientific research and development across the nation. His service on the Scientific Advisory Committee to the Prime Minister of India from 2009 to 2014 provided him with a platform to advise on science policy at the highest levels of the government, demonstrating his dedication to translating scientific knowledge into national progress. Furthermore, Professor Sood's active involvement in the editorial boards of leading scientific journals, including Solicited Communications, Scientific Reports, Particle, and Europhysics Letters, showcases his commitment to the disseminating high-quality research and shaping the direction of scientific discourse. His leadership roles in various scientific institutions, including his current chairmanship of the National Physical Laboratory, New Delhi, further highlight his influence and standing within the scientific community. Professor Sood's career is a powerful testament to the transformative power of scientific curiosity, creativity, and unwavering dedication. He is not only a brilliant researcher pushing the boundaries of scientific knowledge, but also an inspiring mentor nurturing the next generation of scientists, a dedicated teacher imparting his wisdom and passion for physics, and a true leader shaping the future of science through his vision and service. His contributions have not only advanced our understanding of the universe, but have also had a tangible impact on society, paving the way for technological innovations and improvements in human health. He stands as a shining example of scientific excellence and a true inspiration to scientists worldwide. Professor Sood is currently serving as the fourth principal scientific advisor to the Government of India. With this brief introduction, sir, I would like to invite you.
Presentation चलाओ.
I'm really at loss of words, frankly. If that was a brief introduction, I only pity the audience what it would be the proper introduction. But thank you so very much for being so generous in introducing me. Also, I must say a big thank you to our director, Malshaji. I accepted this invitation rather immediately because I thought I didn't tell you the secret because before that somebody had told me this invitation will come and you have no choice but to accept. I will not tell you who, but I was looking forward to it in the sense that I have been associated in one way or the other, rather watching this center grow from the time it started. As was mentioned, I joined atomic energy in way back in 1972 and was there till 1988 and then moved to ISC. And even after that, I have been connected to this center in more than one ways. My very good friend, class fellow, Dr. P.D. Gupta is here. We studied together in Chandigarh. Many of you I know for a long time, and I have seen the tremendous progress this center has made, rather exponential progress, I will call, in the last 40 years. From the time you were in those three sheds and Dr. Bhavalkar's office was in that palace, to this beautiful sprawling campus and extraordinarily well equipped labs, enormous enthusiasm. It really takes breath away. And I must congratulate each one of you for reaching this milestone. It is truly a testament to the work which has been put by all the previous leaders. And I'm so privileged to be speaking, honoring, and remembering two stalwarts of Indian science, Dr. Raja Ramanna and Dr. Chidambaram, with whom, both of whom I had contacts. And only few days back, I participated in the closing ceremony of birth centenary celebrations of Dr. Raja Ramanna in NIAS, where I gave a talk uh, from Vigyan to Vigyan Bhavan, my journey. How from science to science policy I have moved. Uh, so when I had to prepare this talk for half an hour, I thought that would be too much to say, to tell you about my science in the evening. All of you must be tired. But this is a very, very broad brush presentation just to give you a feel of what all of us are thinking. There is nothing extraordinarily new here, but just to think along where we are moving and what country is doing. In this brief presentation, I thought it's a good time to look at where we stand today. So, if you look at India, Global Innovation Index, we have now come to 39th rank from 81st rank in 2014. We have now the patents which are almost 1 lakh. This is 23 figure, 2024 figure was not finally ready. So we took that. Publications, you can see, is almost 2 lakh publications per year. We are third rank in quantity, and PhD in science is almost like 25,000, which is third rank, which are almost competing with what US is. So in this graph, if you look at 2025, our projection is in the blue line will be close to 30,000, and US PhD publication is of similar thing, which is the gray line, and China, of course, is out of scale, which is about 70,000. But it tells you that in terms of human resources, in terms of our preparedness in STEM, we are a force to reckon with. We have to bring in more of the quality along with the quantity, and that is the effort we are making. In startups, which is rightly the right slide after this lab to land transfer ceremony, we are now almost third rank with 1.4 lakh startups. Unicorns are almost 116. And you can look at the numbers, phenomenal increase in number of incubators, 7 times increase in the last 6 years. I think this progress is not isolated. It is a culmination of many, many efforts which have gone over the years, and which has now we have almost 1,400 venture capital firms. It should be much more. We have almost 1,200 incubators and so on. And with this, what we are doing in our office, we are looking at a policy for deep tech startups. So what happens in this 1.4 lakhs? Only 10% can be called deep tech, which are based on high technology. Many of them are, for example, what you are doing, but that number is only 10%. If in a nation, in a nation which has to really become strong, we need to have many, many products which are designed in India, which are made in India, not only manufactured in India. Manufacturing is of course required, but you also need the other aspects. And for that, we have a policy framework which is now being discussed and we hope it will come soon. You must have seen in this budget, 10,000 crore rupees have been put for the startups, and there is a indication that for the deep tech startups, further things will be considered as announced in the recent budget. So this is something which is happening. So I thought at this stage it is good to look at this Australian Strategic Policy Institute, they have come out with a report, and they have listed 64 critical technologies, and they have ranked various countries based on their publications right now. And in that, India ranks within top 5 in 45 of the 64 technologies. China leads in 57, leads means is the first, and US leads only in rest 7 this year, which was totally the different case few years back. And if you look at a few technologies, if you look at biofuels, India comes second, biological manufacturing 10% publication, second rank, advanced composite materials, second rank, and so on. AI, natural language processing, quantum cryptography, cyber security, third rank, quantum sensing, fourth rank right now, but much less, this has to really go up, and drones and robotics, fifth rank. So the reason I put all these statistics is to just tell you the path we are taking to go up the ladder chain in the innovation platform. And this is where all the efforts, I mean, the RRCAT is really the technology hub. It's the pinnacle of development of high-end technologies. And this is where the technologies will spring up in a big way. And I'm sure these numbers will further improve. Some things we need to strengthen. It's not that we are doing everything right. We have about 0.7% of GDP on our R&D. This has to be much higher as compared to other countries, which is almost like 3 to 4%. And researchers per million population is very modest in India. It's only 260 as compared to other countries. If you look at 9,000 for South Korea per million, and so on. So we need to really also have much larger human resource in high-end technology in our STEM education if we really want to compete. But one thing which we need to improve is the percentage of R&D expenditure by private sector in India is about 36%, whereas in many other countries you will see it is much, much more than 50%. This is again, we need to make a framework how we encourage our business partners to invest more in R&D. And the National Research Foundation, which was announced a few months back, has this mandate to bring in the private industry money along with the government funding to enhance the GERD. So this is something the effort is on, and our office has been deeply involved in that. So we have technology vision 2047, starting from research development innovation to make epicenter for R&D, frontiers of technology evolution, digital public infrastructure for which all of us can be proud. DPI, I mean, we have few billion transactions now on the UPI, almost like lakhs of transactions happening every minute, and startup ecosystem growing. So this was just to send a sense of where we are and where we need to go. In all this, we need to look at the Human Development Index, where the countries measure themselves based on health, education, and living standards. Now, on that front, if you look at right now, India is at index is 0.645. This is with respect to the highest one of 1, and the world average is about 0.74. So this has increased over the time, and this is where we need to go when we are talking of really Viksit Bharat and our mission as we go along. And this, there is a correlation of Human Development Index with the energy consumption per person per year. Many studies have been done. And if you look at that, we are somewhere here. We are consuming about 22 gigajoule per person per year, and this is something we need if we need to really go up in chain. So our goal should be to reach a HDI, Human Development Index, of at least 0.9 in next 10, 15 years. And this will not happen suddenly. Lot of effort is needed. And one measure is how much energy consumption we have, keeping the sustainability in mind. So these are going hand in hand. And this is where this is the various states in India, what is their energy consumption, human development index. But the bottom line is we need to really see that our HDI goes up by including all the metrics things, health, education, and all the other parameters. Now, we had a report prepared recently, a few months back. This was done by IIM Ahmedabad, and here they have come out with what are our options for energy transition. Because energy transition, if we have committed net zero carbon by 2070. How do we, it is net zero carbon. It does not mean that you have to stop all energy production. You have to have the right mix that the net zero carbon is achieved. And various scenarios have been put. I will not go over it, but it says that you need all of them. You need even coal, which by 2070, coal will still be needed, but in a form which is not really adding much to the carbon. It will have nuclear in a very big way, which is this, and it will have solar, the yellow one, gas, wind, everything. And this report has been very much instrumental in shaping what our energy policy should be. And now, since all of us are in atomic energy premise, you must have seen the recent announcements on the small modular reactor, Bharat small modular reactor. There is going to be an enormous push, and 5 reactors have been promised, and so on. So all that has to be done along with renewable energy. And one of the source of, along with that, you have to work on carbon capture, utilization and storage. And again, very high-end technologies are needed to really do all of this. Capture, utilization and storage. And that effort has also been going on, but now it is being stepped up. So one of the mission is the green hydrogen mission, where almost 20,000 crores have been given. Actually, it's much more than that for some sectors. And this is something which has been rolled out. It's actually, numbers are much larger. And this is again, our office has a lot of role to play. And we have made various scenarios, not scenario, the policy statements. And like e-mobility R&D roadmap, which was released recently by our office, based on that, there is a mission which has been launched under ANRF to work on all aspects of e-mobility, be it energy storage cells, be it EV aggregates, be it materials and recycling, charging and refueling. So what we trying to do, look at the gaps, look at the policy interventions required, look at the R&D which is required, and then how it will translate. So it has to be the whole cycle which is going to be done. So I think at this stage, with this rather broad introduction, I will give you some feel of where Office of PSA has been playing some role. And if you look at various technologies, this center is really is an example. A lot of things is happening. Advanced space, nuclear and accelerator technologies, quantum frontiers, advanced communication technologies, digital transformation, clean energy technologies, biomanufacturing, biosecurity, One Health. All these are absolutely important if you want to really have Viksit Bharat, or any nation which wants to be really the developed nation, along with the sustainability issues which are paramount. Now, all this is happening. So there are various instruments, policy instruments. So our office, as you know, was made many years back with Dr. Kalam as the first principal scientific advisor. And then we had Dr. Chidambaram for almost 16 years. He was PSA. And then Dr. Vijay Raghavan, R. Vijay Raghavan, was there before I came in 2022, April 20. So uh, in the last few years, in the last 5 to 6 years, many missions have been discussed by this Prime Minister's Science, Technology, Innovation Advisory Council, and we find what are the gaps or what country should be doing. And one of many missions have been launched. They have been cabinet approved, resources allocated. So it's a process. When you make a mission, it does not mean that you will get all what you want. So there is a mission document prepared, DPR, all of you know, cabinet note is prepared, EFC, all that has to go through before it gets implemented by a given ministry. Quantum technology mission is by DST, One Health mission is by ICMR, and AI mission, which was launched last year in 2024, is by MITI, and so on. And Deep Ocean by Ministry of Earth Science. So this is just to give you a feel how the Prime Minister's Science, Technology and Innovation Advisory Council works, and we really see the future. When we talked of quantum few years back in this mission, quantum was not hot. In fact, I made a presentation to Honorable PM when I was a member of PM Strike that this is the technology we should go for. And then, of course, COVID and all that happened. But as soon as we recovered, this mission has been launched with many verticals, and many of you are playing a role in that. So at this stage, actually, there is not much time. I thought, what should we be discussing in this afternoon? So in my view, there are two disruptive technologies which are happening as we speak. One is the artificial intelligence, much more on the scene in the last 1 year, more so on the scene in last 6 weeks after the Chinese invasion of the technology. And the second one is the quantum technologies. These two are really the disruptive technologies. AI is already there in our lives. We are using AI knowingly or unknowingly on your phone and so on. And the quantum is not very far off. So I thought I'll just mention a few things on that, and then probably depending on. So this is something not new. AI is not new. AI started way back in 50s when we had symbolic AI expert system. It went to machine learning, neural networks. Then we have this deep learning revolution, and now generative AI with all the transformer models and so on, large language models. So this is where the world is now waking up to say that it's really affecting the life, and it can affect the humanity in no uncertain terms unless we are careful about it. Oh, this is just a slide to show how I was involved, got exposed to this many years back when we used machine learning to really find out how a glass can de-vitrify. You know, when you have glasses, they become foggy after some time because inside some crystallites grow, because glass is a non-equilibrium structure. In churches, if you go, which are hundreds of year old glasses, you will see fogginess. So depending on how glasses are formed, which are empirically done, this de-vitrification happens, which is very, very detrimental to properties of glass. So there is still no understanding of how this happens, and when will it happen, and where will it happen. So we used machine learning to really predict in a colloidal system, because we wanted to crystallize in few days rather than in few years depending on the life of a PhD student. And we now have experimental ways to and machine learning methods to know where glass will crystallize in a period of time by looking at the parameters much before it crystallizes. So this is again AI ML being used in physical sciences, biological sciences, absolutely in a very major way. So for AI, what do you need? You need three ingredients. You need huge compute power, GPUs for really training and inferencing. You need data, good data to train with taking care of data privacy and security, reliability and transparency and applications. So all these have to be done, and this is what the AI mission has been launched, which is really having all these capabilities. All these things have been rolled out. Compute capacity is being created as we speak. Almost 18,000 GPU capacity will be available very soon in public-private partnership, applications, startups, data set platforms, and so on. So this is something it's happening, but we need to make sure that privacy, ethical consideration, and security are absolutely not compromised. And this is where we had a report recently made. I was chairing it. So what we have done is we have looked at various governance principles. I will not go over it. This is on the website of MITI, and it is open for public consultation till 28th February this year. And we have covered most of the policy framework, which is we are having a very nimble regulatory framework without killing the innovation. But all the possible things have been put in. And if any of you have some suggestions, please feel free to write to us. So this is something has been done, and we have looked at what are the possible instruments we need to bring in. So this is something which you have been hearing a lot in the last 1 month, that how all these things which were talking of, $500 billion investment by US and so on, all that has been questioned with very disruptive technology from China. DeepSeek R1 and R3 have come up, which is an open source model and with revolutionary reasoning capabilities, and another ByteDance and so on. Look at the cost factors, almost reduced by 98%. The reason of showing this slide is to show that unless you have disruptive technologies in a rat race mode, you can never win. So you need to see, rather than having a race following what West is doing, you need to think disruptively. And this is the lesson which we all have, and many of you actually have been doing that in your own ways, where you have new technologies developed in the technology denial regime and all that. So all that, this example of disruptive innovation really is a lesson for all of us to look at. I don't think I'll go over it. There are many areas where AI is part of our lives, and many areas in medical sciences. This is already many startups. This is the recent thing by ICMR, IPR, and Department of Health Research. This has been approved, and so on. And the very big application which was mentioned by director also, the cyber security is a huge issue actually. Millions of attacks happen every minute, and this is where you need AI for cyber security in terms of anomaly detection, proactive security, and a reduction of false alarms. But you also need cyber security for AI. It is both ways. You need securing training data sets from data poisoning and so on. And all these things are really at the core of our digital economy. So you need to have all this if you want to really have digital economy, if you want to be really safe from our adversaries and so on. So all these power grids which we have, how do you make them safe? So enormous effort is happening in the government sector. Trust me, what I have learned in last 3 years, and enormous effort by also bringing private players. So this is a partnership mode, and this is where we need to go. So I think at this stage, I will not really spend time, uh, almost like 2-3 minutes left in my 30 minutes talk. But I would like to just leave a thought with you. And I know some of you are working on quantum sensing. Because we have been taking help from many of you here. Quantum computing is not a choice. It is a must for every nation, because you can easily prove that all these crypto systems, which were thought to be invincible, which would have taken 100 trillion years to break, it can be broken in few minutes to few hours using quantum computers if they improve in their error correction, if they improve in their noise uh, reduction, and so on. So the Shor algorithm is already making waves, because you can really factorize a very large number using quantum computers in a very short time. And that is the reason that it has a global scare everywhere. So all nations are becoming extraordinarily sensitive on really keeping this technology, and this is where each nation has to develop quantum computers, quantum algorithms, and so on. And post quantum cryptography, namely your own classical computers, which they use the crypto now, all those have to change to the cryptography, this thing, which are quantum safe. So enormous effort, even in India, which has been launched, and all this is happening in the quantum mission, which has been launched last year, and we have all the hubs in place and so on. I will not go over all this. This was meant for some other audience. Oh, this is just to shut up. So quantum supremacy will come when you will have the problem solved, which cannot be solved by classical computers. Last month you have seen Google's news. They have solved a specific problem which will take age of the universe to solve in a classical computer. So the specific problems are already being attempted, and for example, drug design, materials design, all these problems which are optimization problems is the one where quantum computers will be absolutely required. So I think we are at a time when we need to look at all these new technologies. I only took two of them, and I'm sure there are many, many more, but it only tells us that unless we do high-end R&D, high-end basic science, which translates to technology and then to market, that's the only way. And I am so glad to see that RRCAT in the last few years has taken a big leap, taking the technology developed here to the market. This has been a long felt need, and happening in atomic energy, happening in space in a big way, happening in telecom sector for a while. So all this is telling us that the holistic approach, by taking R&D in academic sector, in national labs, and in business, in the industry, and taking to TRL 6 to 9 ultimately is the way out. And I think with this, let me close the talk saying quantum sensing. Some of you are making the gravimeters here and so on. I will not talk more of it, but I think with this, let me thank each one of you, and I wish you all the very best for coming years. And I'm sure you have a very big challenges in the industry. I'm glad to see industry efforts are uh, getting fructified. Let's keep our fingers crossed. We will continue to push it that it happens, but I see all the signs that it will happen. And RRCAT is ideally placed with all your experience, all your human resource, all your industry partners to really make it happen. So I wish you all the very best, and it's a very good. Yes. I will do that.
Thank you, sir, for such an insightful presentation, emphasizing the need for technology innovation and underpinning the need of also the artificial intelligence in to be merged with scientific innovations. Uh, Now I request Master Sahab and Pundabegar ji, please come on there. As a token of our appreciation and respect from the entire RRCAT family, I now request Sri Mansur Sahab to present a memento to Professor Sood. This memento is a demonstration of our in-house capabilities and was created using the laser additive manufacturing technology developed by Dr. Christ Paul's team. Thank you, sir. This brings to the end of the ceremony. I now invite Dr. Sunil Verma, Member Secretary of the RRCAT Seminar Committee, to offer the vote of thanks.
Esteemed Chief Guest, Professor Ajay Kumar Sood, sir, Principal Scientific Advisor to Government of India. Honorable Director, RRCAT, Shri Unmesh Malshe ji, Additional Director, RRCAT, Shri Tushar Puntambekar ji, Group Directors, Associate Directors and members of DAC and SCR, RRCAT, former Directors of RRCAT, former Group Directors and Associate Directors of RRCAT, dignitaries, special invitees, friends from the media, dear colleagues, students, ladies and gentlemen. It is my profound honor and privilege to propose the vote of thanks on this momentous occasion. The Foundation Day marks not just the inception of an institute, but it's a celebration of the legacy of the institute. And in our case, it is the legacy of scientific excellence, innovation and commitment to nation building through research and development. First and foremost, I extend my deepest reverences to Professor Ajay Kumar Sood, sir, for gracing this occasion with his presence. Sir, your inspiring words, deep insights, and visionary outlook on science, technology, and innovation have enriched us immensely. Your leadership in advancing scientific research and policy in India is truly commendable, and we are all privileged to have had the opportunity to listen to your words of wisdom. There are several takeaways from your lecture, and we at RRCAT will work diligently on your advice and suggestions. Thank you, sir. The strength of the organizing team is directly proportional to the support and the encouragement received from the head of the institute. We express our sincere gratitude to Shri Unmesh Malshe ji, Director RRCAT, who, in spite of his extremely busy schedule, has taken out time to discuss everything threadbare and provided guidance at every stage of planning, which has been the cornerstone of today's successful organization. Thank you, sir, for reposing faith in us. We also deeply appreciate the support and practical advices received from Additional Director RRCAT Shri Tushar Puntambekar ji, which has helped us avoid many a pitfall. Thank you, sir, for being always available to us. The planning on paper requires a team of dedicated individuals to execute it on ground. I would like to extend our heartfelt gratitude to Dr. Shovan Kumar Majumdar for putting the team in place and leading it from the front. Your passion and unwavering commitment to perfection have been instrumental in making this event a success. Science and technology thrive when ideas are shared and collaborations are nurtured. The Lab to Land ceremony is a testament to that spirit. We would like to thank Dr. C.P. Paul, Head AIC Pi Hub, for his continuous dedicated efforts in this direction. Special thanks are reserved for the industry participants who have come forward with great enthusiasm for taking up the technologies developed at RRCAT and putting them in the public domain. An event of this scale requires synergetic efforts by several colleagues to ensure that the execution is seamless. I take this opportunity to thank Dr. Paul for smooth coordination among in charges of different subcommittees, Dr. N.S. Banerjee for transport arrangements, Srimati Geetika Khare and the team from Computer Division for the glitch-free online streaming of this function to different units of DAE, Dr. Ajit Upadhyay for the arrangements on the stage, auditorium and the guest house, Dr. Srinivas Satpathy for chalking out the arrangements in the auditorium and the lecture halls, Dr. B.N. Upadhyay and Dr. Vikas Jain for arranging the lab visits of dignitaries, Dr. Manoj Kumar Saxena and Shri Vijay Kumar for the hospitality arrangements, Shri Raju John and the entire CSD team for the audio-visual systems, camera and lighting and the floral arrangement you see here. Support and cooperation from the Director's Office, Administration, Accounts, Security personnel from RRCAT and CISF are essential for the smooth execution of any event. A hearty thanks to all of them. Last but not the least, a special thanks to all of you, the attendees. Your enthusiastic presence has made the event memorable. Before I leave, I would like to once again express our gratitude to Professor Ajay Kumar Sood, sir, for gracing this occasion. Sir, as we move forward, we take inspiration from your words and reaffirm our commitment to pushing the frontiers of science and technology for the betterment of society. Thank you all.
Thank you, Sunil. As we conclude our proceedings, I request that you kindly rise for the national anthem. I invite Ms. Ayushi and Amrita to sing the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We invite all the attendees to join us for refreshment outside the auditorium. We particularly request our dignitaries from outside RRCAT as well as the members of DAC and SCR to join us for high tea, which will be served on the rear lawn of the convention center. Thank you.